Okay, in this video we are going to do part 2 of the basics of TCP IP. And the last video we ended with looking at the TCP Dump Command, and I'll just go ahead and recreate that, and then we're going to look at it. So the first thing we were going to do was to load a web page and see what that looks like over here. And so let me get everything ready here. The command that we're going to run is like this. That's what we're going to run. If we want to look at what those options actually mean, that would be in the man page for TCP dump. So we have XX, little I, EN1, and then SRC. So look at the man page. There, the -I is for the interface. That is which network card. EN1 is my wireless card on this laptop. And -X there. So this is printing the data including its link level header in hex and ASCII. So this is basically print everything. That's the print everything option. And the SRC should be pretty self-explanatory. That's anything coming from this, the IP address associated with this. Okay, and then we're going to dump the output into dump.txt. Once I run that, I want to be ready to go ahead and run that. So that's okay. That was asking for my password because I'm doing sudo here on the Mac, and that is running as root. Okay, so I'm going to telnet kennyjeff.com on port 80, and then I'm going to get index.html, HTTP 1.1, host kennyjeff.com. There's the web page. All right, I'm going to go ahead and close this and look in the dump.txt. At some point in time, we see that HTTP/1.1 200, and then we wanted to look at what does the rest of it mean. Okay, I'm going to show you another program that will actually be a little bit easier to look at this. It'll have the same exact data, but it'll be a little bit easier to look at. And that is, let me pause the video. Alright, that's okay. So it's called Wireshark. There is a note here. Wireshark is a packet analyzer. If you search for Wireshark on Google, you'll go to wireshark.org, download it. It runs on anything, so you can get the right version if you're on Windows or Mac or Linux. Okay, inside the program, let me go ahead and stop and close and tell it to start. Okay, so by default, it'll print out, it's going to print out anything that's happening on the network at all. I want to restrict it just to look at kennyjeff.com. And the way to do that, I've already typed it once, and it's going to see that I already did it here. But that's called a filter, so you could look for Wireshark filter IP. and this has some examples here. So this would be, if I use this filter, it's only going to be packets that came from this particular type of IP address, and this would be only going to a particular type of IP address, and that /16 means well, from subnet. We haven't talked about that in the videos yet. Okay, if I want to do this was the IP address for kennyjeff.com, which we can see over here again with I got it wrong, 185. Okay, so that's my filter. I just started over again, and now any traffic going to and from 192.185.5.214. So this program here is showing the same. It's going to show the same data that I had in my TCP dump. There will be display down here. It looks very similar. Now if I do my get again, let's do a reset here. Here, let's just reset it completely. Alright, so I'm going to telnet in, get okay. So now this is, let's see, somewhere inside of here is going to be, so there's http/1. Get http/1.1. That's my telnet program sending this, and all the way up here. When I type this and hit enter, it went ahead and sent that. So that's what this is here. And then host kennyjeff.com, that's me sending it out. You can see here the destination is the IP address for kennyjeff.com, and the source is, that's my IP address at home right now. And then here is the response. So we see there's some HTTP 1.1, 200. We looked at that in the last video. These are the headers that we would see if we were looking in a web browser with your network view. So if we refreshed this here and then look at the response, we had this response that came. That's fine. The response headers are these things here. So over in, so this is showing those headers, and in the TCP dump we can see that as well. HTTP/1.1 200, that's a response, the server, the date, all that information, and then eventually the web page actually starts. This doc type.html is the start of the actual web page code. Okay, so we see the same thing over here, but then this part here is going to explain some of what we want to look at. So let's see. This is the data that was sent back inside of the TCP, and we wanted to look at the header information. So the header information that tells about where this was supposed to go and where it's coming from. Okay, so if I click here on this, then that says this part that's highlighted is TCP information. Okay, so let me browse back up to the top. So that's TCP information related to the Transmission Control Protocol. Everything after that is the actual data. So inside of here, this tells us that there's a port 80, destination port is 60071, and there's other information there. I should be able to find that inside of there. Above that is Internet Protocol version 4, so that's IP data for the IP protocol. And above that is Ethernet 2, so that's Ethernet data for the Ethernet protocol. Alright, we can look at each one of these. This IP protocol should be the one that looks the most familiar. There's those IP addresses that you can see that's displayed up here in the top. Alright, I should be able to find inside of there the hex values for 192.185. So let's look for C0. So somewhere inside of there I should see C0, and there it is. That's 192, and then let's see about 185. B9. Okay, so there's a C0, B9, and if you convert 5 to hex, that's just 5. If you convert 214, that's going to be D6. And then C0 again is the 192 of the destination, and A8 is going to be 168, or 1, and 1D is 29. So that is where the IP address is inside of the IP header information. Okay, now how do we know that that's the right place where this should be in this packet? So for that, we want to go and look at, we had a link to Wikipedia, Internet Protocol Suite. And the information that we're looking at here is, okay, TCP, IPv4, and Ethernet. So let's look at IPv4. I just want to look at the header information. Go down here and there's going to be header. Okay. So here it says is the header information. And there's the source IP and the destination IP, and this is showing 0, 1, 2, 3 bytes. So that's 4 bytes wide. And did I see my source first? That was C0B9. That was the 192.185. That's the source that I'm looking at this particular packet here. Alright, so that's 4 bytes. And then the next 4 bytes is the destination. Okay, so that would say that I'm in this part of the IP header. If I go up the previous 4 bytes, there would be 2 bytes that's something called a checksum, and then 2 bytes that's some other information. If I go all the way back, I should see a version that'll be a 4. So somewhere I should see a 4 if I go back far enough. 1, 2. So that's highlighted blue because IPv4, the previous field, is 2 bytes. That's why it's highlighting it 2. And then there's a 1 byte field, another 1 byte field, and then a 2 byte field. And then the identification is another 2 byte field. Total length is a 2 byte field. And that is hex 5D4, which should correspond. So there I'm at the 05D4. That should correspond inside of here. If I click on it, it'll tell me total length is 1492, and you can see where it's highlighted there, 05D4. If I convert 1492 to hex, I will get 0D. (05D4). Okay, and then looking at what the IP header is supposed to be, that's the total length, and then I had a byte and another byte. So before that 5 was a 0 and a 4-5. And the 4 is the first 4 bits, that's one hex character, and the 5 is this IHL. Okay, then we could look, so we know that the IP packet then starts right here with a 4-5. And we could look in order. The 4 is the version, that's IP version 4. The IHL is 5. Internet header length is a number of 32-bit words, so it's the number of rows here. 1, 2, 3, 4, 5. So that says that the packet ends, the header information ends after the destination IP address. And we were, let's see, this was the source and this was the destination, and that would be the end of the IP header. If we look, so here we had the whole IP header highlighted, and you had C0, A8, 01, 1D. And the next thing after that is the TCP header. So after the C0, A8, 01, 1D, you have the TCP header, and that lines up to having 1, 2, 3, 4, 5 rows here. There's no extra options. This options is if the IHL was greater than 5. There's the IHL. Alright, the next byte is DSCP and ECN. Those are both zeros. Nothing there. Total length we just already looked at was the 05D4. The next was a 2-byte field identification. There's some information there. Let's see what else. That was right here, and then we have a 4000. Flags and fragment offset. So you could look at the flags. And with a 4, that would be, so 4 is bit 1, which means don't fragment. Okay, we won't say what that means right now. Fragmentation offset, that's all zeros. 4000, and then we have a 1-byte field, which is time to live, which is 30. That's hex, and 30 in hex would be 3 times 16, so 48. Time to live. And this is typically set to some value, and every router that it gets to is decremented by 1. That happens, the routers do that automatically. So if we're at the server here trying to send a web page back to the client, every time it hits a new router or switch, that TTL would get decremented by 1, and if it ever gets to 0, then the packet is not forwarded anymore, it's lost, because it might be in an endless loop. So that prevents endless loops from happening forever. Okay, so a TTL of 48, that's what we see right here. Okay, and then we have a 06 for the next field, which was the protocol. So if we see a 6 here, that says TCP. So the IP header there says that what is going to be inside of the IP packet. So inside of the IP packet is everything after the end of the header, and the thing that's after the IP packet is a TCP packet. So you can think of, let's just take a note here. So we have our, let's take a pause. Okay, we'll look here, I typed some notes in. So we have TCP, IP, and Ethernet. Those are the things we see: Ethernet, IP, TCP. Let's scroll in there. We have Ethernet, header, IP header, TCP header. So those are all one after another, and the way we think about this, the way we view it, is that the whole thing is Ethernet information, and so inside of the Ethernet information is some header and an IP packet. So the Ethernet, all of that is bold, and I'll take the IP part and make it all italics. So everything in italics is an IP packet, and that includes the TCP. So the IP packet has a header and it has some body. The IP protocol doesn't say what the body means. It could be anything. In this case, it's a TCP packet. Okay, I'll go ahead and take the TCP packet and underline it. So everything that's underlined is part of the TCP. That has a header that talks about how much data is there, where it's coming from, where it's going, and then it happens to be, in our case, an HTTP, part of an HTTP information. Okay, this way to do things is called TCP IP, those working together. And a good reference, so you can look at, you can read this information, IP protocol, it's a summary of the technical specifications. A good introduction is listed here. This is a good introduction. And I'll copy this. Let's see, why don't we number these? That is 1, 2, 3, 4, 5. Okay, so for this video, good overview is resource 4 above. Okay, so if we look at resource 4, this is information from maybe 10 years ago, but the basic information hasn't really changed. So you want to read this. There's a picture that I wanted to show you. So here is the picture showing that application would be like Firefox, and so Firefox is going to ask for TCP information. The TCP information is going to use the IP protocol to get it, and the IP protocol is using some network interface and physical connection. In our case, it's Ethernet, which is typically what you would see on your computer as well. All right. We were looking through the IP header. We had gotten to the point where the protocol was 6. The next field is a header checksum, and that is going to be used for checking to make sure there are no errors in the packet. So it's going to take all of the data in the header and all of the data in the packet and do this formula. Okay, sorry, only of the header. So this is only computing the checksum of the header. And so if we look here, there's the checksum. So I believe in this program we could turn on validation and it would actually tell us if that matches. So it's going to do this formula based off what's supposed to be in the header, and then put it here, and then we could do the calculation again after receiving it and make sure it matches. And if it doesn't match, then some bits must have changed. All right, and that's the end of the IP header. So the most important thing that's in there are the version 4 at the beginning, and then we see the source and destination IP addresses that we can recognize those if we know what we're looking for. All right, then we would go into the TCP header, which is part of the data inside of the IP packet. And we can look at the table that has the TCP here. So we can go to TCP segment structure, and this has the header. So the first thing we should see is the source port, that's 2 bytes, and the second thing we should see is the destination port, that's 2 bytes. Okay, so 0050 is the first 2 bytes, and EAA7 is the second set of 2 bytes. And 0050, if we convert that to hex, I'm sorry, 0050, that's already hex, so we want to convert that to decimal. What we're expecting here is it's telling us the source is port 80, so let's convert 80 and make sure that matches 50. 50, right. And then if we converted this 60,071 to hex, we would get EAA7. Okay, so that's going in the order that is claimed here on Wikipedia. The next is the sequence number and acknowledgement number, which has to do with the TCP, how it works, which we'll talk about in the next video. Data offset, let's take a look at what data offset is supposed to be. This is specifying the size of the TCP header. The minimum is 5, and that says whether there's going to be extra information. Here we have 1, 2, 3, 4, 5 rows, and let's see what that is. So here's the source port, destination port. Then we have a 4-byte field, that's the sequence number. Then we have a 4-byte field, that's the acknowledgement number. We have a 1-byte field, which has data offset and reserved. Okay, so just the first 4 bits is an 8. So that says that there's going to be 3 extra rows past the standard minimum. Okay, so we were at 8. Now let's see. Source port, destination port, sequence number, acknowledgement number, header length, and reserved. and then we have flags, and then we're going to have window size, which is 2 bytes. Checksum is 2 bytes. Urgent pointer, 2 bytes. And then we have 3 extra fields. 1, 2, 3, 4, that's 4 bytes. 1, 2, 3, 4, that's another row. And then we have 1, 2, 3, 4, that's another row. So the beginning of the data of the TCP packet starts there, and that is our HTTP information. Alright, that's enough for one video. We'll talk more about how the TCP protocol works in the next video.